Hey everybody, welcome back to section P1 again. As you're noticing, these sections are very, very long because this is chapter P. It's all sort of the prerequisites that we need to know from previous years in algebra. So it's very, very long. So keep managing through. You guys are doing a great job. Today let's talk about absolute value. Those of you who've seen absolute value, you know that symbol in math looks like this, sort of the double bars. And when we first learned absolute value, the old way, we said, all right, if you're looking at a number line, and you have 0, the origin, how far is that point from 0? And -4 would be 4 steps away. Or over here, 5 would be 5 steps away. How far is that point from the 0, from the origin? So the absolute value of -4 is 4 steps away. And the absolute value of 5 is 5 steps away. Okay, that's great, but can we think of it now as this new way? Do you notice by those two examples that if I just plug in a real number, when you take the absolute value of that number a, here's what happens. Well, look over here. When a up here was a positive number, as you see right here, if a is positive or 0, you just get the number back out. The absolute value of 5 was 5. The absolute value of 0 is 0. So if a is positive or 0, when you take the absolute value of it, you get the same thing out. Over here, if you notice that when I took the absolute value of a negative number, look what happened. I got the opposite back out. So if a, over here, is a negative number, then you get the opposite of that number. In most terms, we realize that basically what absolute value does is it just makes the number positive. And for most cases, besides the number 0, that is true too. But here's a little bit more of an Algebra 2 honors way of expressing absolute value. All right, let's try these examples. If you've done these before and you feel comfy, go for it on your own and check up with me. Number 6, folks. Part A. All right, I want to find the absolute value here. You see the bars, absolute value of 4 minus 1. Well, by order of operations, we have to do the inside first. So why don't we do 4 minus 1, which is 3. And the absolute value of 3, again, you can use your new way up here. If it's a positive number or 0, you just get that number back out. So the absolute value of 3 is 3. Okay, for part B over here. All right, again, order of operations, we should do the sort of parentheses, or here would be the absolute value. Let's do that first. All right, so we have -3 minus, all right, the absolute value of -3. And it's a negative number. So again, if you want to look up here, when you take the absolute value of a negative number, you just get the positive, or you get the opposite of what the number a was. So the opposite of -3 would be +3. All right, this just becomes -3 minus another 3, and you get -6. Here you go. All right, so what can we do? Absolute values. Here's what you're allowed to do in algebra, some of our great properties. And for the rest of this chapter, friends, you're going to see a lot of properties and a lot of different theorems that you can use in this prerequisite chapter. So if you haven't yet, if you want to just print out the rest of these pages and fill these in, so you don't have to write so much with your hand, it's up to you. Feel free. Again, the blank notes are under our resources page. All right, in general, property number 1. For absolute value, when you find the absolute value number, your answer will always be either positive or 0. Like we saw before, the absolute value of 5 is 5, a positive number. The absolute value of -4 is +4, a positive number. And the absolute value of 0 just gives you 0 back out. Okay, so your numbers, when you get out, will always be either positive or 0. All right, the absolute value of a times b, well, what I could do is I can actually legally break that apart and take the absolute value of a, the absolute value of b, and multiply those two answers together. For example, if a is 4 and b is -2. Okay, well, on the left side, if I take a times b, the left side over here, that would be the absolute value of 4 times -2, which is -8. And that would make it positive, so that would equal 8. Great. But let's see if I can try it over here. Does that work? Let's see. I'm going to take the absolute value of 4 and multiply it by the absolute value of -2. Ooh, the absolute value of -2 is regular 2, right? So 4 times +2, and again, I get 8. So it works. So absolute value works over multiplication. And similarly, if I jump over to 4, I know I'm going a little out of order, But absolute value also works in division. So I can take the absolute value of a fraction, that's the same thing as doing the absolute value of the numerator, and divide by the absolute value of the denominator. And feel free to check that on your own with, say, a equals negative 12 and b equals positive 6. You can see it on your own. Okay, for number 2, last property here, the absolute value of negative a. Well, let me use property 3 for a second. You know, negative a is the same thing as negative 1 times regular a, right? That's what gives me negative a. Well, let me use now property 3. Remember, with multiplication, it distributes with absolute value. So that's the same thing as the absolute value of negative 1 times the absolute value of a. Right? Oh, what's the absolute value of negative 1? Just 1, right? So you become 1 times the absolute value of a, and that's what you get. So the absolute value of negative a is the same thing as the absolute value of just positive a. All right, and now we can use that knowledge to do something like distance between points, which really is not that hard if you think about on the number line. If I want you to find the distance between 2 and 5, you can just say, well, I took 3 steps and I made it. Yeah, but what if it's like really crazy numbers? I'm going to find the distance between negative 72 and 5. Oh, wait, you're going to have to think about it a little bit and figure it out, but you really can't count steps because that would take a long time. So here's a faster way. If I have 2 numbers, let's call them a and b, the way to find distance between a and b is you can do a minus b, one coordinate minus the other coordinate, and if that's a negative number, we're going to take the absolute value of it. Now, one quick thing I just want to say, that's not the same thing as this, my lovely friends. Okay, I can't distribute over subtraction. I can distribute over multiplication and division, but not subtraction. So this is what it is. Now, the cool thing about absolute value is I can actually write it like this too if I want. This should give me the same number. So the distance is either a minus b, absolute value, or b minus a. So subtract your 2 coordinates and take the absolute value. Let's try it. For 7a, let's find the absolute value between negative 1 and 3. What's the distance between negative 1 and 3? And on the number line, you could probably count your steps, and in your brain, you're already like, okay, I think it's 4 steps. But let's prove it. Ready? Let's do 1 coordinate minus the other coordinate and absolute value. Okay, that's minus 1 minus 3 is minus 4. Absolute value, 4. Now, cool. Does it work the other way? Can I do 3 and then negative 1 after that instead? Let's see. Let's do 3 minus the other coordinate. Does this work? Let's see. This becomes 3, and then minus minus is a plus. Oh, look at this, folks. This is pretty sweet. Yes, that's great news for us. So you can go in any direction you want. You don't always have to go left to right. You can go right to left, and it works. All right, try part B on your own, folks, and check back with me. All right, ready? Here we go. Now, just for fun, I'm going to go the other way around. I'll do this number first and this number second. The distance, how about negative 75 minus negative 126. I put the parentheses there so I can just see the double negatives. And I'm going to absolute value. This becomes the absolute value of negative 75 plus 126, or 126 minus 75, which is absolute value of 51. And the absolute value of 51 is just 51. There you go. Now, if you did the other way around, did you get the same number? You might have gotten a negative inside the absolute value, but that gave you a positive overall. So great. Good job on that. All right. Now, let's take a break from numbers, and let's start bringing in letters. And these letters in algebra, if you remember, are called variables. And variables could represent any number. It's a letter that represents any number, really. A lot of times the most popular one, as you see around, is X. But let's talk about when you put these together, variables and actual numbers, which we call constants, you make what's called an expression. And you can combine variables and constants into, any kind of expression using addition, subtraction, multiplication, or division. And now that we're in Algebra 2 Honors, we're going to include a little bit of exponents as well, powers. So can we just practice? Let's evaluate. Let's just practice plugging in values. If I give you this algebraic expression, notice you've got an x as your variable. You've got numbers that are constants like 4 and the negative 6. What's the value when x equals 2? Okay, well, again, this x is sort of like a placeholder. We take that 2, if you remember, and we're going to substitute it back into the game. So this becomes 4 times x is 2 minus 6, which is 4 times 2 is 8 minus 6, and you get 2. So the expression 4x minus 6, well, when x is 2, my answer is 2. If you feel comfortable doing this, friends, why don't you do part B and C on your own and check back with me. Okay, for part B, when x is negative 1, let's plug that back in. How about 4? X is negative 1. Notice that nothing else changes. 4 times negative 1, and you keep going. Minus 4 minus 6 is negative 10. For part C, when x is 0, let's substitute him in. We get 4 times x is 0. Ooh, anything times 0 is just 0. So the expression 4x minus 6, when x is 0, you get negative 6. Pretty good, right? All right, why don't you pause the video, and can you now try it for these next 3? Here's your new expression, and let's plug in for these 2 values. Sorry, 2 expressions here. Good luck. All right, for part A, here's our expression of 9 minus 7x, but now x is negative 3. That is 9 minus 7 times x is negative 3. I get minus 7 times a minus 3 is a positive 21. Answer for A. There you go. For part B, about 9 minus 7, x is now 3. And there you go, friends. So those are algebraic expressions, and what we can do with them when we plug in x values is just substituting them into the game. Let's keep going. We're on a roll. Okay. Now, again, another good page just to print out on your own, so you can just fill these in with me. So we've gone over these in pre-algebra and algebra 1 days, but again, let's just review what we're allowed to do in algebra days. So every letter here, A, B, and C, are all real numbers. Real numbers. Or they could also be variables, or overall just algebraic expressions like you saw on the previous page. But here's what we're allowed to do. Here are all the basic properties that we have in algebra, friends. First property, if I take A plus B, A plus B, well, you know what? It's the same thing as just doing B plus A. And we call that the commutative property of addition. You can see why it's addition because you have a plus sign, and commutating, like you commute, commutative, when you commute to work, you have to go back. So A plus B gives you B plus A. Example over here on the right, you could say 2 plus 5 is the same thing as 5 plus 2. All right, that property is done. Check. Next property. How about A times B? A times B is, okay, it's commutative, so if you go to work, you have to come back. A times B is the same thing as B times A. So this is commutative property, but you see it's not addition, this is multiplication. Commutative property of multiplication. Example, let's use the same numbers. How about 2 times 5, which you know is 10. The same thing as I've just multiplied the other way around. It still works. Property, check. Okay, here's the associative property coming up here. Associative property just means you can associate the different terms in different order. So here you see A plus B in parentheses, so I would do that first, and then I would add the C later. That's the same thing as doing, how about B plus C first, and then adding the A second. Do you notice how the parentheses are just associated with a different pair? So it's called the associative property of addition. Good example? Let's do, how about 1 plus 3 on the outside plus 4. Let's see, that should be, by this property, the same thing as what if I grouped 3 plus 4 together first and then add the 1 afterwards. Let's just check if this is right. Okay, 1 plus 3 over here is 4, and 4 plus 4 should give me 8. Sounds good. How about on the right-hand side? Does this work? It says we should do 3 plus 4 first, okay, and then add the 1 afterwards. Well, look, yay, 8 equals 8. So the associative property does work. It also works for multiplication as well, so check on that one. Associative property of multiplication, again, just means I can multiply A times B first and then multiply my answer by C, or, can you see it? Let's multiply B times C first and then multiply that answer by A. So the changing parentheses show that you're associating different terms in different order. Let's use the same numbers that we did up for addition here. Let's do, how about I do 1 times 3 first, and then multiply your answer by 4. That should be the same thing as, what if I do 3 times 4 first, and then multiply your answer by 1. And you can double check that by multiplying that now. Associative property of multiplication, check. Oh, distributive. I love distributive. And the cool thing about distributive property, do you notice that there's nothing after the word distributive property? Like there's no of multiplication, of addition. Well, because if you notice here, distributive actually does both. There's addition inside the parentheses, and then there's multiplication afterwards. So it's kind of a best of both worlds here, right? So here is what distributive property does. Distributive property looks like I'm going to add inside and then multiply your answer on the outside. That's fine. Or we could literally distribute the outside number, the a, into each piece and multiply them like this. A times b and a times c, and then add your two answers. Similarly, on the second one, we could distribute the c sort of backwards. And you could get c times a, or I'll put it in alphabetical order, and c times b, and add your answers. Sometimes this first one is called the left distributive property because you can see the a is on the left. I'm multiplying in from the left. So does it make sense that this one is often called the right distributive property? Because you're multiplying in from the right. That's distributive. We like that one. That one's kind of fun. Have an example here on the right. How about 2 times 3 plus 4? That should be the same thing as 2 times 3 plus 2 times 4. And feel free to multiply and add those together, and it should work. And if you want to check by putting the 2 on the other side and trying a right distributive property, you should hopefully get the same thing. Okay, we're moving along, folks. You're doing great. How about the additive identity? The additive identity says, what number do I add to a letter A and get A back out? What can you add to a number and just get the same number out? And that number is 0. A plus 0 is just 0. So that's called the additive identity. Identity, think of getting the same thing back, yourself. If you take yourself, what do you add to yourself to still get yourself back out is 0. So that one's check. Distributive property, check. Same thing with identity, but let's do it with multiplication. Same question. But now, would you multiply A by to get A back? Not 0, right? That would be different. This one, you're going to multiply by the number 1. 1 times a number gives you that number back out. So what gives you A back out when you multiply? The number 1. Number 1 is called the multiplicative identity. Check. Okay, now we can do what's called the inverse. The additive inverse says, what do I add to a number to get 0 back out? So what do I do to a number, for example, 4? What do I add to it to get 0? Oh, I have to add negative 4. Oh, okay. Well, notice the sort of the relationship between 4 and negative 4. Negative 4 is the opposite, or we could use the word inverse, of the original A, of the original 4. So the additive inverse is you take the opposite number, A plus negative A gives you 0. So negative A is called the additive inverse. Check. And finally, friends, last one. Same question, sort of, but now would you multiply to get the number 1? Why 1? You'll see in just a second why. But for example, if I take the number 3, what do I multiply 3 by to get 1? It looks like it's probably going to have to be a fraction. And in fact, it's going to be 1 over 3. And similarly, can you see that the relationship between 3 and 1 over 3? One of them is sort of the reciprocal of the other, or in multiplication we can call that also the inverse. The reciprocal or the inverse of the number 3 is 1 over 3. So what did you multiply by? If you take A, you multiply by its reciprocal or its inverse. That's called the multiplicative inverse. All right, there you go. There's all your properties, friends. Nice job. Now, what can we do with them? Let's illustrate what we got so far and how we can apply this. All right, look at each one, A, B, and C, and can you figure out what rule of algebra we're using here? All right, part A. Well, I'm taking 2 and I'm multiplying by 1 over 2. So I'm taking a number, I'm multiplying by its reciprocal, by its inverse. I'm multiplying by its multiplicative inverse. There you go. There's the multiplicative inverse property. Because I multiplied by its reciprocal, its inverse, and I got 1 back out. Feel free to go back and double check. And yep, that's the same one right here. A and 1 over A. How about for B? For B, it looks like I have a 5 multiplying 2 minus 3x. And I get this. How did I get that? Oh, it looks like 10 I got from doing 5 times 2. And the negative 15 was from doing minus 5. Ah, I see. See what I'm doing? I'm multiplying and then sort of adding or subtracting afterwards. That's called distributive. I distributed the 5 in. That's the distributive property. You can say that this is the left distributive property, but we're not really too picky about that. All right, part C. Let's see, so I'm doing 3 times an xy, but then on the right side, I'm doing the 3x and then the y. So I have the same terms, but it's like I do them in a different order. So it's like I moved my parentheses and I associated them, hint, hint, with 2 other terms. I did it in a different order. Did you get it? This is the associative property. But which one, though? Is this, are we adding or are we multiplying? Oh, we're multiplying, right? So this is the associative property of multiplication. Should we check that? Let's see. All right, scroll up here. Yep, there it is. Look how I associate the parentheses in a different order, the associative property of multiplication. Great job on that. So hopefully that was a little bit of a review, but good to bring that back. All right, why don't we end with this right here? How can we do negatives? How do negatives affect us in algebra? And I like this section because it's really important. Because whenever we make any kind of algebraic errors or mistakes, a lot of times it happens with negatives. They're really hard to play with sometimes, friends. So same rules here. We got A and B are real numbers or variables or algebraic expressions. Property number 1. All right, if I take a number A or an expression A and I multiply it by -1, that's the same thing as just saying negative A. For example, if A is 4 and I'm going to multiply by -1, I just get the opposite of A. I get -4. So multiplying a number or an expression or a variable by a negative number just makes it negative, or it changes its sign. All right, number 2. Check. Number 2, if I take the opposite of the opposite of A, like we talked about before, the double negatives become a positive. So we just get that this equals A. Example, let's take the opposite of -3. And then you know that the 2 negatives become a positive, so we get just 3. Check. Property 3. All right, -A times a B. Okay, well, let's see what I could do here. I could say, by using sort of property 1 in a way, I can say it's the same thing as just -A, and then I'm multiplying by the B. All right, cool. So it looks like the negative goes just all the way on the outside. It's A times B, and I make it negative. Or I could also say that negative can go into the B if I want. Now that's multiplication, not subtraction. But these 3 are all equivalent. They're all the same thing. There's only one negative really overall. It's either -A and then you multiply by B, or you can make the B negative multiply by positive A and just move the negative around, or just do A times B and make the whole thing opposite sign. For example, let's do -2 times 5. Okay, in your brain, you know that -2 times 5 is just going to be 10, right? But let's use this property. Is that the same thing as overall -2 times 5? Yep. Oops, I put negative there. Mr. Brown. Sloppy. Do you see that's the same thing as, what if I made the B, the 5 negative? So let's take the 2 and multiply by, put the negative on the 5. That's also -10. So it does work. Forgot the negative on that. Mr. Brown, sloppy. That's okay. Forgive me. Check. Number 4. All right, I've got 2 opposites here, 2 negatives. So what we could do is, we could actually take both of those out. If we have a -A and then multiply by the -B, and then why don't we take the negative on the B out, so that'd be sort of a negative A times B. Right, so I took both negatives out because now I can sort of use property 2 and see that the two negatives make a positive. So negative a times negative b just gives you a positive ab. For example, negative 3 times negative 4. You can take both the negatives out and just do 3 times 4, and that works as well. Or if you can see that both negatives cancel and I just get positive 12. Check. Last one, friends. Oh, you're doing a great job. Number 5. All right, I've got negative parentheses a plus b. So because of the parentheses, and I've got addition or sometimes subtraction inside, I want you to think of this as almost like distributive property. I'm going to change the negative to an actual negative 1, because that's really what you see on the outside. I know it just says negative, and we don't always have to write the 1, but I'm going to show you why I'm doing that. Because now, by the distributive property, I can multiply the negative 1 in. That becomes negative 1 times a plus negative 1 times b. And again, just use property 1 twice, basically. Negative 1 times a is minus a, plus negative 1 times b is negative b. Or you can just simplify it as negative a minus b. Okay? You can use numbers for that, but that works as well. So again, just using distributive property, can you multiply the negative into both pieces? Good job, folks. We're still going through section P1, and we're almost done. We've got one more video that we'll do later, and we're almost finished with the first section. Great job today, everyone. Check.